Today, we will study about data link protocols. Imagine two friends talking. To avoid confusion, they take turns speaking and listen carefully. Data link protocols are like conversation rules for network devices to ensure smooth data flow. Think of them as the etiquette for data communication between devices on a network. They manage how data is broken down into packets, transmitted and received without errors. Let's discuss about simple protocols. These are theoretical protocols used for understanding basic concepts. They may not be practical for real-world scenario due to inefficiency. Unrestricted simple protocols means just imagine one friend constantly talking without waiting for a reply. This is inefficient and can lead to missed information. Now we will discuss about stop and wait protocol. That is, a sender transmit a data packet and wait for an acknowledgement, that is ACK, from the receiver before sending the next packet. Let's take an example of it. Think of two friends taking turns speaking. One person talks until they get a nod, that is head nod, which is the acknowledgement from the other before continuing. This concept is stop and wait protocol. But what is the limitation of this protocol? This can be slow as the sender waits even if the network is clear. Imagine long pause between sentence if one friend needs to take a sip of water after every sentence. Now we will discuss about piggy banking. It is basically a optimization technique where the acknowledgement, that is ACK, for a received packet is included in the data portion of the next packet being sent. Let's take an example of it. Imagine two friends combining short messages. One friend might say, "I got your point," and also, "The weather is nice today." What is the benefit of this piggybacking? It reduces the number of packets required and improves efficiency. Now, we will discuss about MAC, that is Media Access Control. This is a crucial in scenarios where multiple devices share a single network medium, like a cable. It defines how devices take turns for transmitting data to avoid collision and ensure efficient communication. There are different types of MAC protocols like random access, controlled access, and channelization. Next is random access. Basically, devices transmit data whenever they have it, without checking if the medium is busy or not. Let's take an example. Imagine a group discussion where everyone talks whenever they have a thought, leading to potential overlap and confusion. The best example of it is Aloha protocols. Next is controlled access. When devices follow a predefined order or protocol to determine who transmits data and when, is known as controlled access. Let's take an example of it. Imagine a meeting with a chairperson who controls who speaks and when, ensuring everyone gets a chance to be heard. The example in computer network is CSMA/CD, that is Carrier Sense Multiple Access with Collision Detection, which is used in Ethernet. Next is channelization. It divides the available transmission medium, like a cable, into multiple channels or time slots, and devices are assigned specific channel or time slots for transmission. Example is, imagine multiple radio stations broadcasting on different frequencies to avoid interference. In network, the example is FDMA, that is Frequency Division Multiple Access, which is used in cellular network. Next is polling. The central device, that is poll master, asks each device on the network one by one if they have data to transmit. Now, what are the advantages of it? It prevents collision and efficient for predictable traffic patterns. Let's take an example of it. Imagine a teacher asking, "Does anyone have a question?" Students raise their hands to indicate they have a data, that is a question. The teacher then calls on a specific student and grant access. That means, "Yes, Mr. X, please tell me, what is your question?" Now, what is the disadvantage of it? Introduces overhead, that is extra messages for polling. Can be slow if many devices are inactive but need to be polled. Next is token passing. A unique token circulates on the network. Only the device holding the token can transmit data. Now, what's its advantage? Fair access for all devices. Efficient for both heavy and light traffic. Let's make it simpler by an example. Imagine a talking stick passed around the circle in class. Only the student holding the stick can ask a question. That means transmission of data. What will be the disadvantage of it? Single point of failure, that is, if the token is lost or communication halts, then requires more complex hardwares and protocols. It makes the situation more complex. Now, the question is how to choose the right protocol. The best protocol depends on factors like number 1, network traffic, that is, how many devices are using the network. Number 2, latency requirement, that is, how important is real-time communication. Number 3 is error rates, that is, how susceptible is the network to errors. By understanding this concept, you will be able to give answers. Please give the answer on the comment section of this video. Thank you. Thank you for watching.